time-driven simulation induces and executes events for a fixed time interval, let's say delta t. It looks for events that may have occurred during fixed time interval. If it finds some events or a single event, such events would be executed as if they occurred at the end of the interval. After the execution, it advances the simulation clock by delta t. Let's consider an example. The basic idea is time advancement in a time-driven simulation. The curved arrows represent such advancements. A, B, and C mark the occurrence of the events. During the first interval, no event was occurred. The second interval contains A, which is not handled until the end of the interval. Time interval delta t is an important parameter for time-driven simulation. A large interval, for example, if delta t is large number, it can lead to loss of information. And a very small interval can cause unnecessary waste of computational efforts. Suppose events B and C in the fifth interval are packet arrival and departure events, respectively. Since these two events are considered to occur exactly at the end of the interval, that is delta 5, the system state would be as if there is no packet arrival or departure occurred during delta 4 and delta 5. This is considered as a loss of information. An example of waste of computational effort occurs between delta 2 and delta 4. Although no event occurred in this interval, the simulation wastes the computational resources to stop and process events at delta 3 and delta 4.